At that ratio, 12 divided by 22.5 gives you a 0.56 ratio. That's a little bit higher than we estimate the minimum water level to be under worst case conditions. So we apply a 0.5 allowable ratio. Multiply that times 7850 gives you 39,300 times the 0.1 baffling factor, because this tank has one inlet and one outlet and no internal baffles. You get a 3,938 gallon effective storage volume. Let's go to the bottom half of the form and talk about how we use that. This line 9 is basically what we just came up with, the 3938. Now I need to talk about total capacity of the tanks feeding, of the wells feeding the tank, and the total capacity of the pumps that are drawing from it. You've got to enter those two pieces of information. So if you've got a 400 gallon per minute well and a 400 gallon per minute well, this number will be 800 because both wells can come on at the same time. Now, if your control system only allows one of those two wells to come on at any given time, then it will be 400 because that's the total capacity of the wells feeding this tank under normal conditions. The total capacity of all the service pumps that are fed by the tanks, you just add up the capacity of all the service pumps that are taking suction from this tank and enter that number. You got 1,000 gallon per minute pumps, you put 2,000 in there. The flow rate used for CT calculations is the minimum of these two values. And it's the minimum of these two values for a very good reason. If your output exceeds your input, the water level continues to fall. And by definition, we have said that the water level in the tank is at its minimum. It's not going to fall any further. If the input flow rate exceeds the output flow rate, then the water level will rise in the tank because you're not pumping it out as fast as you're putting it in. But by definition, we're at the minimum water level. At minimum water level, input equals output because we've reached a steady state condition. Okay? Now, if I've got large capacity service pumps and I've got this small well pump, how does input ever equal output? Because the evaluation that you guys do for 4-log viral is based on a 4-hour compliance period, you're in compliance as long as that number doesn't drop below your minimum specified residual for more than 4 hours. You haven't violated the rule. We're looking at a peak hour period. Like I said, the well pump comes on at 16 feet and it continues to run until the tank fills back up to 22.5 feet. So it's going to run continuously during the period when the service pumps are running intermittently. So over this 4-hour period or over this 1-hour period, the service pumps and well pumps are balancing one another. The well pump runs continuously, the service pump runs intermittently. But the total amount of water moved by both of the service and the well pumps is going to be equal during this period when water level is at the minimum. Okay? The T10 for this site is just taking the effective gallons divided by the flow rate, and it calculates the T10 detention time within that plant. Why do we use T10? That's a really good question. Joaquin asked me that question. The reason we use T10 is because that's the point at which 10% of the water slips through the treatment unit, the contactor, faster than the other 90%. So by using T10 rather than some theoretical time, T50 or T80, we're assuring that 90% of the water that passes through that tank has achieved more disinfection than is required to meet the rule. The amount of water that passes through the tank from 0 to 10% may have received a little less disinfection than is required by the rule. But a lot of studies have been done where they inject a tracer into the storage tank and track the output of that tracer through the storage tank. And it's like when you have T10, T1% is really close to T10%. So by using a T10% value or T10 value for the contact time, we're getting pretty close to 100% disinfection. Okay? Now, the next line is the CT required for 4-log viral inactivation if the water temperature is 10 degrees or higher, or really 10 degrees, and the pH of the water does not exceed 9.5. This is where a huge simplification of the program occurred. When you're using free chlorine, the CT required under those conditions, 10-degree water temperature and a pH no greater than 9.5 is 6 milligrams per liter per minute. The C, milligrams per liter, times the time in minutes, okay? Now, if you're using a different disinfectant or your temperature is higher than 10 degrees, which by the way is 50-degree water, and there's not a lot of groundwater in Texas anyway that's 50 degrees. So when Joaquin was telling you earlier that just because you don't meet minimum specified doesn't mean you're necessarily violating the rule, it's because we have made some very conservative assumptions here, okay? But this spreadsheet only works because the number for free chlorine at 10 degrees is 6. We take the 6 and we divide it by the number of minutes we have in the actual contact, and that gives us the residual we're required to have in order to meet 4-log virus. This line right here is the minimum specified residual value, okay? MSR. All right, now this MSR can vary by entry point, so you're going to have to do one of these templates if you want to use this compliance strategy. You're going to have to develop one of these templates for each one of your entry points that are fed by groundwater sources if you want to use this for that site. Let's go to the next slide and talk about the example. Remember we had 3938 of effective capacity? We've got 2 wells at this site. One well pumps 192 gallons per minute and one well pumps 58 gallons per minute for a total of 240, and at this plant both wells run simultaneously. This plant has 2 400-gallon per minute service pumps. So when we calculate the detention time, the T10 time for this facility, we'll divide 39 time for this facility, 3938 by 240, and end up with a T10 time of 16.4 minutes. Dividing the 6 by 16.4 gives us a residual of 0.4 milligrams per liter, okay? Now, let me give you 30-to-1 ratio is so important, okay? If we have 30 gallons of storage, the most credit you can get for that tank is half value. So you end up with 15 gallons of allowable credit. Multiply that times 0.1 for the baffling factor, that gives you 1.5. When you divide 6 by 1.5, you get 4. 4 milligrams per liter is the MRDL for free chlorine. We're not going to let you leave the plant with more than a 4 milligram per liter free chlorine residual because we don't want to take any of the complaint calls you're going to get. Okay? So that's where that 30-to-1 ratio comes from. It's a mathematical balance. You have more than 30-to-1 ratio, you end up with a lower minimum specified residual. Now for most plants that meet the state's 200 gallons for every 0.6 GPM per connection requirement for storage versus production, this number is going to be way lower than what is actually required when the water leaves the plant in order for you to maintain a residual out at the end of the system. So there will be very few systems that have ground storage and use free chlorine that won't be able to use the minimum specified residual for compliance purposes. But it falls kind of back to what Joaquin was saying earlier. It's an economic decision. There are monitoring and reporting requirements associated with this and with all the other compliance options for the groundwater rule. Whether this compliance option suits your plants is kind of an economic decision. Let's go to the next slide and talk about what happens if you are using some other disinfectant or you don't have storage or you want to claim credit, you've got baffles, you've got all kinds of stuff. You're going to have to use the surface water CT study template. It's a much more powerful tool. It deals with other disinfectants like chlorine dioxide and ozone. It allows you to claim credit for pipelines. It allows you to claim credit for tanks that have internal baffles. It allows you to claim credit for tanks that are in series, because the groundwater CT study spreadsheet only applies if the tanks all fill and drain together. That is, they're operating in parallel. Now, although this is a much more powerful form, I don't think that many systems will use the surface water template. But if you've already used it to demonstrate 4-log virus, the one thing you've got to do is to go back in and make sure that you have a letter from us that says, okay, here's my minimum specified residual based on what I did on the surface water CT study template. Now, I think the next slide is my last one. Oh, no, I got one more. Submitting a CT study. Any public water supply representative can submit the CT study. You can use your consulting engineer, the utility director can do it. The plant operator certainly has all the information necessary to complete the form and submit the request. You can even get the mayor to do it, as long as he's not an Aggie. No, just if you can get the mayor to do it, you can get the mayor to do it. But when you complete the template, send it to the Drinking Water Protection Team, DWAP, at this mail code, and be sure that you tell the folks that this is a groundwater CT study, so that they can send it to the right guy. I think that pretty much wraps up my presentation, Mike, and if there are any questions, call Joaquin.